All right, so let's see this particular problem now. So in this problem, we are given an array which contains only zeros, ones, and twos, right? Only these three numbers. And what we need to do is we just need to sort this particular array in ascending order, right? So essentially, after we sort this particular array, since there are only three numbers in this array, we will get all zeros in the beginning, then ones, and then at the end, we will get all the twos, right? So that's what we need to do. For example, if this is my input array 0, 1, 2, 0, 1, 2, then I have to like return this particular output, all the zeros in the beginning, ones in the middle, and then twos at the end. Essentially, we need to sort the array in the ascending order, right? So this is what we need to do, and we need to do it as efficiently as possible, right? So now maybe you can just pause this video and try to think of a solution, and also try to think of a solution which gives you better time complexity than order of n log n, right? Because order of n log n is something that you can do with normal sorting also, but I mean, you have to think of some other efficient solution which gives you better time complexity, right? So now maybe you can just pause this video and try to think of a solution. And once you are done, you can just come back and check the solution here. Okay, so now to solve this particular question, see, the one observation that we will be using in this solution is that we are given only three numbers over here, right? So if we move all the zeros, right, towards the beginning and all the twos at the end, right, we will essentially be able to sort this particular array, right? Because then if we have already moved all the zeros in the beginning and we have also made sure that all the twos are at the end, then obviously only all the ones will be in the middle, right? And we will have all the zeros together in the beginning, ones in the middle and twos at the end, right? So our goal should be that, you know, as and when we are encountering any zero, we make sure that it goes towards the beginning, right? At the very beginning. And whenever we encounter a 2, we make sure that it is gathered at the end, right? And whenever we encounter a 1, we don't do anything. We can just keep it like that, right? So that should be our goal, right? But how to do that, right? So now we can maintain two pointers over here, right? Let me actually write it over here. We can maintain two pointer. One can be a left pointer, right? And I can initialize it with 0, right? That is the 0th index. And I can also initialize another variable right to n minus 1, which is the size of this particular array. N being the size of this array, we are saying that right pointer will be pointing to the last index of this particular array, right? So now I have two pointers. Now what I'm saying is that at any point in time, I will ensure that all the elements before this L pointer are zeros, right? And all the elements after this right pointer are twos, right? That's what I'm going to ensure at every point in time, at every like iteration that I'm going to do. I'm going to traverse this particular array. Like that's quite obvious, we have to do that. But in every iteration of this traversal, I will have to make sure that all the elements before this L pointer are zeros and after this right pointer are twos, right? And at the end, right, at the end of the entire traversal, I would have sorted this particular array because I would have, made sure that all the zeros are brought to the beginning and all the twos are sent to the last, right, to the end, right? That's what I will be able to ensure by using these two pointers while I'm traversing this particular array, right? By making sure that all the zeros are before L pointer again and all the twos are after the right pointer, right? So that's what we need to do. And see, to start with, see my, initially my left pointer would be over here, right? And my right pointer would be here. Let me actually write it like this and write it like this, right? So this will be my left pointer and this will be my right pointer. And initially we haven't like, encountered any zero or any two. That's why we don't have any element before left and we don't have any element after right, right? So once we start encountering any zeros or twos, we will just keep like decrementing the right pointer. We will just keep moving the right pointer towards the left and we will just keep moving the left pointer towards the right after, we have put that particular zero what we encountered before, this particular left pointer, right? So that's what we have to do. But now how to do this, right? How to actually bring all the zeros before the left pointer and all the twos after the right pointer. What we can do is we can now actually traverse this particular array and we can use another pointer now. I mean, we can use, I can just write it over here. I can use another pointer. I can, again, I'll have to start with the 0th index. So I will initialize it with 0, right? That is over here. Now what I will do is at every index, I will check if my value at the ith index is 0, right? First of all, that's what I'm going to check. If it is 0, then I'm going to swap, the value that is 0 at the ith index with the current value of the left pointer, right? I will swap these two, right? And then after swapping, I will just increment my left pointer by 1, right? So this will ensure that, the 0 that I actually encountered at the ith index has been placed at the left pointer, and then the after that the left pointer has been incremented by 1, right? So now the 0 is before the left pointer, right? And I'm going to do with this with the all the zeros that I'm encountering. I'm just going to swap it with the current value at the left pointer, at the current left pointer, and then after doing that swap, I'm going to increment my left pointer by 1. So this will ensure that after I have encountered all the zeros, after I have covered all the zeros, they will always be before my left pointer, right? The current value of my left pointer, and I can be sure of that, right? Similarly, if I'm encountering any 2, right, at my ith index, right, when I'm traversing this array, I will just swap that particular value, that is 2 at the ith index, with the current value at the right index, right? I will just swap those two, and then I will just decrement the value of the right pointer so that it moves towards the left, right? And so in this way, when I have covered all the 2's in this particular array, I would have made sure that, all the 2's are now before my right, I'm sorry, after my right pointer, right? Because I have been swapping them with the current value of my right pointer, and thereafter I have been decrementing my right pointer by 1. I've been moving my right pointer by 1, towards the left after doing that swap, right? So that way, all my left, like all my zeros at the end would be before my left pointer, and all my 2's will be after my right pointer. I will keep doing that swap, right? And whenever I encounter a 1 at the ith index, I will just do nothing, right? I will just move on. Because at the end of the day, when we move all the zeros and 2's at the uh, beginning and the end, ones will be anyways falling in their place, right? So that's the entire algorithm. That's what we need to do. We will have 3 pointers over here. One will be the left pointer, right pointer, right? And an I pointer to basically traverse this particular entire array and keep swapping as and when we are getting zeros or 2's, right? With left or right pointer respectively, right? So that's what we need to do. And maybe you can just try to code this particular algorithm now. Even that would be good if you are able to do that. And if we talk about the time complexity and space complexity, see time complexity, we are just traversing this particular array once, right? We are not doing anything else. We have an I pointer. We are just, traversing this array, and we are doing constant time operations in every traversal, right? We are just swapping the two numbers, right? So it will be order of n, the entire time complexity of this particular solution. And since we are not using any space, we are doing everything in place. In fact, we are not even creating any other array for outputting the result. The space complexity will again be order of 1, and it will be constant, right? So that's the entire algorithm. Now maybe we can just jump to our IDE and code this particular solution. All right, so now let's implement the solution that we discussed. So to begin with, let me just declare a function over here. I can call it as the sort 0, 1, 2, right? And then this will accept an integer array. And first of all, what I can do is I can capture the length of this particular array in a variable n, right? Then I can declare my left pointer and initialize it to 0. Also declare my right pointer and initialize it to the last element of the array, that is n minus 1. And then I can declare my I pointer, which I'm going to use to traverse the entire array. And this also I can initialize to 0, right? Because I'm going to start from the leftmost index and go till the right, right? And after I've done this, now I can run a while loop, and my condition would be while I is less than or equal to r, right? And why I is less than equal to r and not I less than n? Because see, I'm saying that, at every point in time, I will ensure that all the elements after my right pointer are all going to be 2's, right? So that's why at the end, once I reach this particular right pointer, when my I becomes equal to right pointer, I can be sure that all the upcoming next elements after this right pointer will be 2's only, right? There will be nothing else. So they will always be like they will already be sorted, and they will already be in their right place. So I don't have to do anything. So I can just stop over there, and I can come out of the while loop, right? So that's why this particular condition. And now what I can do is in every iteration, I need to check if my current element is equal to 0 first of all, right? If it is equal to 0, I will just swap it with the current value of my left pointer, right? So I will just say, swap my current value of the I pointer with the current value of my left pointer like this, right? And after doing this swap, I will just increment my left pointer by 1, and I will move to the next element. And this way I'm saying that, before this left pointer, right, all the elements are zeros, right? Currently, the left pointer might be like pointing to some different element other than a non-zero element also. But then before my left pointer, all the elements are zero. That's why I swapped first the left point, like the current value with the left pointer, and then I incremented the left pointer by one, right? So I hope this is clear. And now if, the current element is not zero, I will check if it is equal to 2, right? If it is equal to 2, I will do the same thing, but with the right pointer. That is, I will swap the current value of the ith index with the current value at the right pointer, like this, right? Like this. And then I will decrement my right pointer by 1, right? So that I move my right pointer towards the left now and ensure that all the elements at any point in time after my right pointer are all 2's, right? So that's what I'm doing over here. And if it is neither 0 or 2, I can just conclude that it is a 1. And so if it is a 1, I don't have to do anything. I can just ignore it and move to the next element. That is, I will just increment my I pointer, which I'm using to traverse each and every element of the array. I will just move that particular pointer to my towards the right, to the next element. So that's what I'm doing over here. And once I have done this for all the elements, once I come out of the while loop, I will have the sorted array. Like I will have the input array sorted in place. So I don't even have to return anything because I'm making all the changes, all the swaps in place inside of this particular array, right? So this will actually give me my final output. But before we can conclude, there is a very small corner case that we need to handle. So for example, let me explain you through an example over here. So for example, this is my input array, right? 0, 1, 2, 0, 1, 2. Now, if I try to trace this particular algorithm on this particular array, so to start with, my L pointer will be pointing over here to the 0th index, and my I pointer will also be pointing to the 0th index over here, right? So when I come inside of this while loop in the very first iteration, this condition array of I equal to 0 will become true, right? Because indeed it is 0. And so now I will just swap the value at my current I index with the current value of the L index, right? And so I will end up swapping this element with this element itself because both the L and I are pointing to the same element, right? So which is fine. It is not going to make any change. I mean, it won't do anything wrong over here. But then after doing this particular swap, I'm incrementing my left pointer by 1, right? So after this particular iteration is done, my left pointer will come over here to 1, right? And my I pointer will still be at 0 over here, right? So now in the next iteration, again I will check if my array of I equal to 0, and again this particular condition will hold true because my I index is still over here at the 0th index, right? And now I will again do this particular swap, and when I do this particular swap between the current value of I and the current value of L, my 1 will come over here and 0 will go over here, which will become wrong, right? And so to actually handle this, I have to ensure that at every point in time or at any point in time, my I pointer is always greater than or equal to my left pointer, right? It is never lesser than my left pointer, right? That's something that I have to ensure. Over here, if you see, I'm always ensuring that my I is either lesser than or equal to R, but it is never greater than R, right? That is something that I've already handled in the condition of my while loop itself, right? But I also have to ensure that my I is like in a similar fashion always greater than equal to my left pointer, right? And that's why I have to like check that if at any iteration my I becomes lesser than L, right? I can just increment my uh, the I can just put an if over here first of all. Yeah. If my I becomes lesser than L, I can just increment my I pointer by 1, right? And see, I'm only incrementing by 1 because see, I'm going to check this particular condition in every iteration, right? And in the same iteration, whenever like after I'm incrementing my left pointer by 1, if after incrementing that particular left pointer by 1, if this particular condition gets true, that is my I becomes less than L, then I can be sure that the difference by which my left pointer is actually greater than I, it will be 1 only, right? Because I'm going to make sure that I'm checking this particular condition in every iteration, right? So that's why I will just, increment my I pointer by only 1 if I ever find that my I is less than L, right? And that will make I equal to L, right? After incrementing my I by 1, right? So that's how I'm going to handle this particular corner case, and I'm just going to like make sure that my I is always greater than equal to L, right? And anyways, my I will always be lesser than equal to R, right? And that's a very like a small thing, but the main core idea is that we are going to swap all the current zeros that we are encountering at any element with the current value at the left pointer, and if I encounter any 2, at the current element, current I index, I'm going to swap it with the right element and also like increment the left pointer by 1 and decrement the right pointer by 1 respectively, right? Whenever we are encountering a 0 or a 2. So that way we will just ensure that all the zeros we are moving towards the beginning before the left pointer and all the twos we are moving after the right pointer at the end. And anyways, ones we are not doing anything. So ones will be there as is and they will be falling in between my left and the right pointer, right? So that is the entire implementation of the algorithm. I hope you understood it well. I hope it makes sense to you. And now maybe we can just quickly test it as well. So this is the sample array that I have anyways written over here. So I can just print it first of all, and then I can call this particular function on this particular array. And then again, I can print it because see, I'm making this particular change directly on this array in place, right? Whatever array I'm passing as an input to this particular function, I'm just making the changes in this particular function in place on the input array, right? So what I'm doing is first I'm printing this array, I'm calling this particular function on this array, and then I'm printing again, right? Just to see the change. So now if I run this, you can see that initially this was my original array 0, 1, 2, 0, 1, 2, and after calling this sort 0, 1, 2 function on this array, the array got sorted and it became 0, 0, 1, 1, 2, 2, right? So this is the entire solution, and as we discussed, the time complexity of this solution is order of n. As you can see, we are just traversing this particular array once, right? And we are not doing anything else. And space complexity is anyways constant, so it will be order of 1. We are not using any auxiliary space over here, right? So that's it for this particular question, and I will see you in the next one. Thank you.